output shaft component inspection. Visually inspect the teeth of both gears and both synchronizer rings. Set the blocker rings onto the gear and press down while rotating the blocker ring. The ring should grab and bind on the gear. A blocker ring that freely spins under pressure is worn out. Check both blocker rings and their mating gears. Don't mix them up. The gap between the blocker ring and the gear dog teeth can be measured with a feeler gauge. Be careful not to push the blocker ring off the gear while making this measurement. You may have to use two feeler gauges that are next to each other. I have a 22 thousandths of an inch and a 23 thousandths of an inch for a total of 45 thousandths of an inch. Apply even downward force on the blocker ring while using the feeler gauge to measure the gap. Make sure the feeler gauge goes straight in for an accurate measurement. Notice how easy it is to push the blocker ring off the gear while attempting to make this measurement. Move the feeler gauge around the gear while feeling the measurement. The gear has a cone shape and the blocker ring has a reverse cone shape. As the inside of the diameter of the blocker ring gets larger from wear and tear, the blocker ring will sit closer to the gear. This will reduce the clearance. Perform the same test on both gears. The factory manual specifies a maximum clearance of 24 thousandths of an inch for both gears. This terminology can be confusing. What they are trying to say is that any measured value of 24 thousandths of an inch or less is bad, and anything greater than 24 thousandths of an inch is good. One test that is not in the book is to see if the blocker ring will wobble on the gear. Apply downward force on two opposing sides of the blocker ring. Then apply the same downward force 90 degrees apart from the first. If the blocker ring does not sit square on the gear, it will rock back and forth or wobble. Try this in multiple locations. Perform this test on both gears. If the blocker ring does not wiggle or rock back and forth, then it passes this test. Inspect the synchronizer keys for wear and groove marks. A close inspection of both sides of these keys revealed ghosting or witness marks, but none of the markings were grooved or indented. Inspect these with the edge of a small screwdriver or your fingernail. Inspect the springs by setting all three of them side by side, standing up on the bench. Check to see that they are the same height, the coils are not distorted, and they are straight. So this synchronizer uses a C-spring instead of the coil spring design, but inspection is going to be very similar. So we're going to look at this hub to see if there's any damage in this area right in here, as well as the splines. But what will be really important, we'll be looking at these splines right in here for any damage or wear marks, as well as on the very edges on both sides. And this hub is clearly different. This hub sticks out. The boss area sticks higher on this one versus on this side over here. And if we were to look at this particular hub, we would be able to see there's a really small hairline crack right here. And that's going to be problematic, so we have to look really carefully at that. You might be able to see it as well over on this side over here. When we look at the synchronizer sleeve itself, since this sleeve has the teeth for reverse, we're going to look at these reverse teeth to make sure they're not damaged. We're going to look at where the synchronizer fork sits right in here on the sides. We're going to be looking for wear on those sides. We're also going to take a really close look at the teeth right down in this area, these clutching teeth. We want to look at both sides to see if you have any abnormal wear or these things are rounded off right in this area right in here. And finally, we can't see everything. So we're going to line this up. Now remember, this cutout right here lines up with the cutout on your hub. And we're going to make sure that this slides nice and smooth through here. So this should slide nicely. If we lift it up sideways and we just hold it and we just stick our fingers in here, this should slide smoothly back and forth like this. And sometimes we do a drop test where we'll hold this up just a little bit above the table and see if it drops through like that. And we'll do it both ways. We already inspected the keys earlier. It's a little bit different key, but we would inspect these keys for damage. We see some ghosting marks here, but my fingernail reveals that those are okay. And I could even use a small screwdriver and check for any imperfections or raised edges. Some keys are made out of a stamped sheet metal, so sometimes if you look at them from the side, you'd be able to tell whether or not they're bent. So we'd be looking for bent keys. These would not bend, these would break. The way to assemble this synchronizer is, one, you have to make sure you know which side of this deep hub goes with which side on my synchronizer here. And so I happen to know that these go in this way. So I'm going to go ahead and line this synchronizer hub up like this. Then your keys would be put in, making sure to get the bump on the key that goes outwards. So put your keys down like this. Then your spring goes in. Make sure you get the edge of your spring caught underneath the key. Bring it all the way around and get it up underneath this other key right there. Now when you put the other one in on the other side, you don't want to have it just like this. You actually want to have it like this. So if there's spring tension in the area that there's no spring tension. So I'm going to put my finger here so I know where that gap is at, so I can make sure that when I put this one in, it will not have the same gap area for this synchronizer. So that's been properly assembled. One other note to make, on some synchronizers you'll actually see two little holes, and those little holes are actually designed for the springs on these C springs. And so it has an extra long tip right there, and that extra long tip is designed to fit in that hole as it goes around, and the other one goes the other way so that we make sure that we have the spring on the other side, and this one's missing that spring. This is an example of a worn synchronizer hub. The splines are severely gouged. The gouges are visible from another angle. This is a close-up of a synchronizer sleeve clutching teeth that are in good condition. The teeth on this sleeve are severely ground down and worn out. This sleeve was paired with the worn hub I just showed you. This transmission had heavy grinding noises every time it was shifted.